let's talk about geometry. Geometry is the concept of shapes, triangles, and triangles and stuff. In 8th grade math, we talk about moving them, flipping them, rotating them, making them bigger, making them smaller, trying to find the missing side of one, trying to find the missing volume of one. You know, it really all depends. But it's the idea of taking shapes and manipulating them and solving for them. In this first problem, we are being asked to graph triangle 3, -4, or A, which is 3, -4. So when you're graphing a point, remember, this is the x value, and this is the y value. So the x value determines left or right. The y value determines up or down. This is a positive x, so we're going to go right 3, and a negative y, so down 4. So right 3, down 4 gives me that point right there. You are A. B is 5, -6. So B is 5, -6. Excuse me. 1, 2, 3, 4, 5, 6. I'm dying. Oh. Call the police. And C is 1. Right 1. Down 1, 2, 3, 4, 5, 6, 7. That is my C, and here is my triangle. Now I'm being asked to reflect it over the y-axis. So what I'm going to do is I'm going to draw a line on the y-axis. The y-axis is always the vertical up-y down-y axis. And now we just take turns moving things dot by dot. Okay? So B, or this is C. C is 1 unit away from the line. So C prime is also going to be 1 unit away from the line. B is 1, 2, 3, 4, 5 units away. So B prime is 1, 2, 3, 4, 5 units away. That's B prime. And A is 1, 2, 3 units away. 1, 2, 3. A prime. Then translate A prime up 6 and left 1 and call it double prime. All right, I can do that. So I'm going to go up 6, left 1. Up 1, 2, 3, 4, 5, 6, left 1. That is A prime, double prime. B is up 1, 2, 3, 4, 5, 6, left 1. That's B double prime. And C is up 1, 2, 3, 4, 5, 6, left 1. That's C double prime. This shape didn't change size. It's still the same exact shape that it was at the very beginning. I just flipped it and moved it up and to the left a little bit. That's it. That's it. That's it. That's it. Name the 4 quadrants and write out the point values. I can do this. All right. Quadrant 1 is always the top right. Quadrant, and then it goes counterclockwise. I don't know why the math people decided this, but that's what they decided. Quadrant 3 is the bottom left. Quadrant 4 is the bottom right. Quadrant 1 is a positive x value, a positive x value, positive y value. So that's going to be positive, positive. Quadrant 2 is going to be a negative x value, positive y value. Left is negative x, up is positive y. Quadrant 3 is left, down. So left is negative x, down is negative y. And quadrant 4 is right, down. So right is positive x, down is negative y. All right, so if I was given a point like 5, 8, I'd go right 5, up 8. If I was given the point negative 5, 8, I'd go left 5, up 8, so on and so forth. If the shape in quadrant 1 was rotated 90 degrees clockwise, if the shape in quadrant 1 was rotated 90 degrees clockwise, what quadrant would it be in now, and what type of point would it have? 90 degrees is one turn. So 90 degrees would go here. 90 degrees clockwise would go here and go 1/4 turn. And so that would be quadrant 4. And the type of point would be positive, negative. If a shape in quadrant 2 was rotated 90 degrees counterclockwise, so here's quadrant 2, here's counterclockwise, one turn. What quadrant would it be in now? Quadrant 3. And what type of points would it have? Double negative. Triangle A, 3, -4. B, 5, -6. C, 1, -7 is dilated with the scale factor of 1/2. Find the coordinates of A prime, B prime, C prime. No graph. Dilating means you take that scale factor, take that number, and multiply 1/2 to each and everything here. So 3 times 1/2 is 3/2. So A prime is going to be 3/2. -4 times 1/2 is -2. You can use a calculator for all of this if you need to. 5 times 1/2 is 5/2. -6 times 1/2 is -3. Move my face. And C is going to be 1 times 1/2, which is 1/2. And -7 times 1/2, which is -7/2. If you use a calculator, this might be -3.5, 2.5, 1.5. It's all the same. All right, so practice 6, we're going to skip several problems because it doesn't have anything to do with 8th grade math anymore. So if you see me skip a few, no big deal. For example, we're skipping 1. Which sequence of 2 transformations changes the left triangle into the right triangle? Now, I don't like this problem, but I think what it wants us to do is if we were to flip and move it to the right, we would get this guy. So I'm going to, or we can move to the right and flip. That's fine too. So I think the answer is B. I don't like it, but B is saying if we take this shape, right, translate it to the right, and then reflect it over a vertical axis, which it won't let me do here. So basically imagine that picture and flipping it. That's what we get for 2. So I don't know. That's what I'm saying for 2. ABC is dilated by a scale factor of 2 and then rotated 90 degrees clockwise. The result is labeled DEF. Triangles ABC and DEF must be. Okay. So if I take a shape, and do I have scrap paper laying around? It doesn't matter. I don't need scrap paper. If I take a shape and I make it bigger and then I rotate it. So let's take a shape. That's just any random shape. Dilate it, make it bigger, rotate it. What happened? The result is obtuse, but I don't know. Similar? Well, yeah, they are similar. I mean, one is just like a bigger version of the other one. Congruent? No. Congruent means exactly the same. Equilateral? No, because that's not equilateral. So it's similar. If you take a shape, similar means it's the same exact shape, but one's just bigger than the other. And that's what I did. Same exact shape. One's just bigger than the other. A parallelogram PQRS is rotated 90 degrees counterclockwise. All right. PQRS. I can't label them because it won't let me move it. Is rotated 90 degrees counterclockwise. Okay. The result is labeled the primes. The sides PQ must be, well, if it's a parallelogram, they must be parallel. That's pretty easy. Triangles ABC and XYZ are similar. The measure of A is 50 degrees. Which of the following must be true? Well, one angle and the other one must be 50 degrees. If they're similar, they're the same shape. So if they're the same shape, they're going to have the same exact angles. They're going to have different side measures, but they're going to have the same exact angles. So if they're similar, they're going to have the same angles. The answer must be C, because if this guy has an angle of 50, then that guy must have an angle of 50. Okay, we're skipping that because that is not 8th grade anymore. That's 7th grade material. Trapezoid is rotated 90 degrees counterclockwise about the origin. What must be the location of M? All right, normally what we would do is we would take this guy and write it out on paper and actually move it. I can't do that here. I can't. So I'm going to use some common sense. Here's M. Rotating this guy 90 degrees counterclockwise is going to go this way. Okay, so what I'm doing is I'm saying I'm going to pretend M is a ball on a piece of string. And if I take that piece of string and move it down 90 degrees, it's going to make a 90-degree angle, see what I did, and live right there. So that's M prime. Now, I already knew that this whole thing is going to go in quadrant 3. Which is negative, negative, which eliminates U, which eliminates U. So that gives me one of two options. So at the very least, I could take a wild guess. But I know the answer, because it creates a 90-degree angle, is going to be -1, -3. That's my M prime. The answer is B. Normally what I would do is, in fact, it's going to look weird on your end, but I would take my paper and I would focus on M and I would rotate it and say, all right, well, my shape just moved to the bottom left, and the way I get to M is left 1 down 3. So what's left 1 down 3? B is left 1 down 3. A couple different ways that you can approach this problem and still be right. Which of the following best describes the movement from figure 1 to figure 2? Well, this means rotate, so it's not U. And it's not U. So is it 90 or 180? Well, 90 is one turn. So 90 would move figure A, which looks like this, up top. That's not what I want. I want it completely flipped around, which is a 180. Line segment AB has endpoints at 2, -6, and 8, -6. It is reflected over the x-axis and then translated 4 units to the left to get A prime B to get A prime. All right, so this is what I'm going to do. I can't steal any of these graphs, or can I? I can. I'm going to steal this graph on the left here. And I can't graph I can't graph B. And if you're like, why? Why can't you graph B? Well, because B has an 8 on it. So I'm going to graph A and do what this tells me to do. A is 2, -6, so 2, -6 lives down here. It is reflected over the x-axis, which is this line right here, reflected over the x-axis. So A is way down here, So reflecting it over here is going to be 1, 2, 3, 4, 5, 6 units away. 1, 2, 3, 4, 5, 6 units away. So that's A prime. Now it's translated 4 units to the left. 1, 2, 3, 4. That's A double prime. What point is that now? Left 2, up 1, 2, 3, 4, 5, 6. Left 2 is -2, up 6 is +6. -2, +6 is my A, not you, not you, yes you, not you. If I had to do B, then I would do a similar thing. And there's nothing wrong with looking for a coordinate plane somewhere else in your test and using it. If you want to draw your own, great. But I'm just going to boonk gang it. I'm just going to boonk gang it. Boonk gang means to take. I could also use the word yeet or skirt. Translate the rectangle 5 units right and 2 units up. What is the coordinates of the translated figure? So let's do 1 point at a time. 5 right, 2 up. So let's take this guy and go 1, 2, 3, 4, 5, 1, 2. Put a dot. Do they have letters? Nope. That is right 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5. So that's 6, 5. So let's see if we can eliminate any answers. 6, 5. You could be it. B doesn't have a 6, 5. C doesn't have a 6, 5. And D doesn't have a 6, 5. Well, that just makes my job so much easier. Thank you, multiple choice. I would do the same thing to all the other dots if you needed to. What is the smallest turn that will rotate this figure onto itself? Basically, what can I do? And I'm just going to draw the picture like this. I know it's not an exact... Oh, you know what? I know I can't. Watch this. Watch. Check out what I do. I'm going to use my smartboard. Smart. All right. 180 turns it upside down. Now, that does get itself. But... is it the smallest turn? 120 is 1/3 of a turn, so 1/3 of a turn would look like that. Oh, that's definitely not it. 1/4 of a turn. Oh, it is itself. Nice. 45 degrees is 1/8 of a turn, which looks like that. So it's going to be 90 degrees is the smallest turn that you can do to make it turn onto itself. 180 is correct, but not the smallest turn. Before I even look, it looks like that's a reflection over the y-axis. So it's D. You might hear my baby screaming upstairs, or my 3-year-old. She's not a baby. She's just insane. It's a reflection over the y-axis. It's not a translation because it's a mirror image. It's not a rotation because it's not upside down. It's a reflection over the y-axis. This arrow, okay, the shaded arrow is the result. So we're going from this guy to that guy. How am I getting there? All right, well, a reflection across the y-axis. I'm just going to pretend that this is an arrow pointing to the right. Wow. Pretend that this is an arrow pointing to the right. If I reflect it over the y-axis, oh my goodness gracious, let's move my face. If I reflect it over the y-axis, then what it does is it makes my arrow point to the left. Okay? If I reflect it over the x-axis, it's still going to keep it as an arrow pointing to the left. So it's not that. It's not A. So to me, it's some type of reflection and then translation. That's my guess. A reflection across the x-axis would have this reflect so that it's still pointing to the right, and then translation 7 units to the right. So let's see. If I reflect it, It's in between the 3 and the 4, so it stays in between the 3 and the 4. 1, 2, 3, 4, 5, 6, 7. I like it. I like it. I like it a lot. This is not 8th grade, but I like it. It's easy. This is a right triangle. All triangles have 180 degrees in it, so this is 90. And you care about R. So 180 minus 90 minus 35 is going to be 45 degrees. You don't have to know this for 8th grade math, but it's easy. It's easy. More? Yeah, more. Two angles of a triangle measure 24 degrees and 76 degrees. So let's just do that one quickly because it's not that bad. 180 minus 24 minus 76. It's going to be 80. Pretty simple. We're going to skip 17 because it's not 8th grade math anymore. They're going to skip 18 for the same reason. Same thing with 19. Same thing with 20. A triangle in the coordinate plane has vertices -4, -4, 1, 3, 1, and 1, 5. It is dilated by a scale factor of 2. Okay, so all I need to do is just take, I don't need the graph. All I need to do is just take those points and multiply each of them by 2. So I'll write that down here so I can see. So that'll be -8, 2, 3, 1 becomes 6, 2, and 1, 5 becomes 2, 10. Let me see, -8, 2, 6, 2, 2, 10, A. Pretty easy. That's all I had to do, right? I'm not missing anything, am I? Yeah, okay. Okay, what are the coordinates of the image using a scale factor of 3? Dilation of a scale factor of 3. So let me write down my 4 corners here because I need to multiply them all by 3. So let me write down my 4 corners. Boom, 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 boom. The one on the bottom left is right 1, up 1, which is 1, 1. And then right 1, up 3, that's the top left, which is 1 positive 3. Then I have right 3, up 1, which is 3, 1. And then I have right 3, up 3, which is 3, 3. I am multiplying by a scale factor of 3, which means all of these get multiplied by 3. So 1, 1 is 3, 3. 1, 3. Wow, the lag is so bad. 1, 3 becomes 3, 9. 3, 1 becomes 9, 3. And then 3, 3 becomes 9, 9. Three, 3, 9, 3, 3, 9, 3, 9. What is the motion rule for the dilation? Well, if I'm multiplying everything by 3, then it's going to go from xx to 3x, 3y. So xy to 3x, 3y. This means you would get smaller. Scale factor would be a third. This means you go right 3, up 3, and this means you go left 3, down, up 3. Yeah. Right 3, up 3, left 3, up 3. All right. Triangle below is rotated 180 degrees. It would be very easy for you to be like, it looks like this, but it doesn't look like that because remember, when you take something and rotate it, you're looking at it upside down. You're literally hanging it upside down. So it's not going to be that. It's basically going to be upside down, and the upside down version is going to look something like that. I know it's not perfect, but that's the upside down version. Don't believe me? Then take your picture and spin it upside down, and you can be like, oh yeah, you're right, I see it now. Simple. So it's not A. It's not, just let me draw red lines everywhere. It's not A. It's not B, although B is tempting. Looks like C, not D. Look at this. Our first open-ended. Only took us 6 packets. On the coordinate grid below, ABC is reflected across the x-axis to get A prime, B prime, C prime. Then A prime, B prime, C prime was translated left 8 to get the image A double prime, B double prime, C double prime. Very similar to our warm-up, so let's do it. Draw and... Oh! It's backwards. I didn't even know. Look at the picture that we're given. This is the answer. So I need to work backwards to get the original. How strange. All right, so then I go backwards. If A prime, B prime, C prime turned into this by going left, then I have to go the opposite. I'm working backwards. So I'm going to start out by going right 8 units. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. And that's C regular prime. 1, 2, 3, 4, 5, 6, 7, 8. And that's B regular prime. 1, 2, 3, 4, 5, 6, 7, 8. And that's A regular prime. Tricky. Pretty sneaky, sis. It's from a movie. I don't remember which one. Then what did we do? Reflected over the x-axis. Well, that's not going to change. Reflected over the x-axis. So C regular. B regular. It looks like A is 5 up there. So 1, 2, 3, 4, 5 is A regular. Draw and label A prime. Okay, I did. What are the coordinates of the vertexes of A, B, C? Well, A appears to be right 1, down 5. So A is right 1, which is positive 1. Down 5 is negative 5. B is right 1, down 1. Right 1, positive 1. Down 1, negative 1. And C appears to be right 3, down 1, which is positive 3, negative 1. Tricky. Tricky stuff. Tricky. That does it for packet 6. Hope you had fun. Bye.